I like knowing where I am. Often when I'm building something in MakeCode for Minecraft, it helps my mental map to have the directions displayed in the Minecraft world so that I don't get mixed up when I'm specifying coordinates. So I built a little compass that's designed to be used as a background for other programs. There are some very nice compasses that on the Microsoft Minecraft site, but they are kind of center stage, and you wouldn't use them generally to build something else. So let's look at what I call Handy Compass. And what it does is it, first of all, puts a gold block under the player's feet, and then it prints each direction in the sky, starting with plus X, which is east, plus Z, which is south, minus X, west, and minus Z, north. Now, if I wanted to build a fence, I would start building a fence right at this gold block, and I could imagine which way my fence was being built because I would have the directions to reference in the sky. Now let's look at the code. The code consists of one main command called compass and 4 functions, one for each of the 4 directions. And notice they all look rather the same, and they are, except their coordinates simply specify the print command at a different position in the sky. And I guess you noticed that when we were looking at each direction, it read left to right when the player was standing in the middle. So, and that's of course what you would want it to do. Now let's take a look at the code a little more closely to the code. Okay, so I implemented this as a chat command, not a function, because it's very interesting that this will run asynchronously. That is, it will run while another program is also running, and I'll show you an example of that towards the end. So in all of my programs, I start and end by saying that the program is indeed running. And then the first thing this program does is it tests to see if the variable origin has been set. If it's null, then it has not been set. Generally in my programs, I set origin only once, and origin is usually level with the ground where the player is. Of course, the player could start in the sky, but I actually drop origin to the ground and keep the X and Z of where the player was. And that's what this code does. The first statement takes the X position of the origin, takes the Z position of the origin, and then it sets origin to the player's original X and original Z, but it sets it at 4, which in world coordinates means it's where the player's feet would be if the player were on the ground. Then I like to print this out just so that I have confidence. And then I place a gold block at the origin plus that is a mistake. This should not be relative. This should be a world position so that it's just a number. And it's, so the origin, and then the only coordinate that's changed is the up down, and that would be -1, which means it puts that block level with the ground. Now then this chat calls east, south, west, and north, and then it's done. Now let's take a look at one of these. functions. So the east function first says it's running and what it is. It then has a variable called tempx, variables tempx and tempz, which are set to the coordinate of origin, but then a value is added to it. And the value added depends on which direction we're using. Here is east. So to the x coordinate of origin, we want to add 50. That puts it out in front of the player 50 blocks. And then z is set to minus 20. And z is basically where the printing starts. So we want to print it over, start it over to the left a bit so that it ends up kind of centered on where the player is looking at. And I arrived at this by trial and error. And frankly, I think this might be better to be minus 10. I need to futz with it probably a little bit more. Then the print command. So we're going to print plus x, which is east. We're going to use whatever kind of block we want. And then it's going to be at world coordinates temp x, temp z, which are calculated above, but then I'm going to put it 20 blocks high. Since it's way out 50 blocks, I need to put it up in the sky so that the player can easily see it. And obviously, if you wanted the this 20 can be changed, and also 50 can be changed in order to customize the compass to be the way you would want it. Now, each of these other functions are pretty much like the first one, but their x and z coordinates will be different depending on the function. And also, something else to notice is the most interesting part of the print, I think, or the hardest for me to get the hang of, was the along. It's going to print towards the south, sorry, and that will make it read left to right. So you need to wrap your mind around each of these. Took me a while to get the hang of it. So if you're, so that and of course you can do this by trial and error because there are only 4 ways it could be. And at first what I did was actually try them in order to get them to read left to right from the center position. But then I sat down and very slowly sort of drew out and convinced myself that yes, indeed, that is the way it should be. Okay, that is the code. So let's look at one more example. We're just going to use this same world, but we're going to use some different code to see another example. And I'm just going to use cityscapes, which is something I've been working on. And what this does is, I think I should start with a clean world. So I'm going to save and quit. This is what I do every time. And this was the world I was using, so I'm going to delete it. I don't like to get my cluttered up with lots of worlds. So then my sandbox, I want to copy it because it's set up the way I want it, and then I open it, and I have a clean whole world. Now, I'm going to run city. And I want about 30 buildings. Now, city, there they are building the buildings. Now, what's interesting is city runs while compass, the chat command city launches the compass command at its very beginning. So notice it's printing the compass as the buildings are being drawn. So these are running asynchronously, meaning that they're both running conceptually at the same time. Now, on a computer, unless they're using parallel processors, they don't really run at the same time, but they're interleaved so that they seem effectively to run at the same time. And I really came to understand this when I was debugging because I had used some global variables, and it took me a while to figure out I'd use them both in Compass and accidentally use the same names in Cityscapes. So since it kind of changed differently each time, it was hard for me to figure out what the bug was. And sure enough, the variables were being changed by the other program. So I had to be careful about using names that were not also used in the other program. So that is Compass, a very handy little gadget.